The topic for Lesson 4.3 is relations. You'll learn how to represent relations as sets of ordered pairs, tables, mappings, and graphs, and how to find the inverse of a relation. Can relations be used to represent baseball statistics? Ken Jeffrey Jr.'s batting statistics for home runs and strikeouts can be represented as a set of ordered pairs. The number of home runs are the first coordinates, and the number of strikeouts are the second coordinates. You can plot ordered pairs on a graph to look for patterns. Recall that a relation is a set of ordered pairs. A relation can be represented by a set of ordered pairs, a table, a graph, or a mapping. A mapping illustrates how each element of the domain is paired with an element in the range. Study the different representations of the same relation below. We've got ordered pairs, a table, there's x, there's y. We have plotted the points, so 1, 2, -2, 4, 0, -3. And the mapping, if I know x is 1, the y value that corresponds to it is 2, -2 corresponds to 4, and 0 is x, then y is -3 in this relation. For example 1, we get a try expressing the relation in this list of ordered pairs as a table, a graph, and a mapping. A table is a really convenient way to make our list. We've got the x part of the coordinate in the first column and the y in the second. We've also been practicing plotting points. So here's 4, 3, -2, -1, -3, +2, +2, -4, and 0, -4. And then in the mapping, we would write 4, 3, -2, -1, -3, +2, 2, -4, and 0 also goes to -4. And then they ask us to determine the domain and range. The domain is just a list of the numbers in the x position. So 4, -2, -3, 2, and 0. Order doesn't matter. If you look in the book, they will organize theirs because they like to, but it doesn't have to be. It's just a list. 3, -1, 2, -4. Notice I only listed the -4 once. When writing the elements of the domain and range, if a value is repeated, you need only list it once. The table shows the percent of people satisfied with the way things were going in the U.S. at the time of the survey. 1992, we had 21%. Ooh, 32%. Wow, 1998 was a good year, 60%. 2001, 51%. They ask us to find the domain and range. Domain is usually our independent variable, which time is always independent. So there's our years, and the range is the dependent variable, so there's our y values. Then they ask us to graph the data. They've given us a very nice graph here. They labeled the vertical axis with our dependent variable, the percent satisfied, the horizontal axis with our independent variable, the years, and plotted the points, and the label for the entire thing was percent satisfied. And then, of course, they plotted the points. And then the question that statisticians would want us to answer: what conclusions might you make from the graph of the data? I kind of said that as we were looking at the data. Americans became more satisfied with the country from 1992 to 98, but the percentage dropped off from 98 to 2001. The inverse of any relation is obtained by switching the coordinates in each ordered pair. The relation Q is the inverse of relation S if and only if, for every ordered pair A, B, and S, there is an ordered pair BA in Q. Example 3 asks us to express the relation shown in the mapping as a set of ordered pairs, then write the inverse of the relation. The original ordered pairs are 5, 1, 7, 2, 4, -9, and 0, 2. When we do the inverse, 5, 1 becomes 1, 5, 7, 2 becomes 2, 7, 4, -9 becomes -9, 4, and 0, 2 becomes 2, 0. In summary, a relation can be expressed as a set of ordered pairs, a table, a graph, or a mapping.